Let's go over power rule in this video. So you worked on difference quotient and limit definition of derivative enough, really. We did a lot of algebra work, right? So in this lesson, we will do something a little different, okay? We're going to talk about something called power rule, and you will very much like it, I know, okay? It makes it so much easier, okay? So let me get this note started, and I'll ask you to look at some patterns for me, okay? I'm going to take derivative of a whole bunch of functions. And what you will do is you will find the pattern. Okay, well, I should talk about what finding derivative means. Okay, we say the process is differentiating. Okay, you know how to, for example, like if you are to find a sum, right? When someone tell you to find the sum, you know that's the same thing as add, right? Or someone may say find a quotient, right? What are they telling you to do? They're telling you to divide, right? Same thing. What you're going to be asked to do is you will be asked to find a or I should say I'll say find the derivative. Find the derivative. And the process of this, okay, finding the derivative, we say the differentiate. Okay, so whenever you hear or you read the direction that is telling you to differentiate, or find the derivative of, or what are some different ways, find this y prime, okay? They are telling you to find the derivative of y or derivative of f, of the f of x. But how do we do that? We did it the longer way, okay? So from now on, you guys, you and I will be differentiating like crazy. We are going to be finding derivatives of so many different functions. But the first couple sections, I will talk about different rules. Power rule, some difference rules. There is also called product rule, quotient rule. Those are for next week. But let's practice a rule called power rule in this video, okay? Why are these rules important? Why are these rules going to be good for us? Because remember what we did, all that work. The limit definition, of derivative requires you to do multiple lines of work, simplifying the difference quotient, then plugging in h equals 0. It's a lot of work. To remind you what all that was about, if I go and open up the notes that we did during class yesterday, can open it up. And this is what I scanned from our class yesterday. It's all this. We were differentiating yesterday. We were finding the derivatives yesterday. We did all that hard work, right? And we had to do lots of FOILing, multiplying, simplifying like terms, canceling out some opposite terms, and then that's how we found this derivative. I will show you a method called power rule that will let us skip all these lines of work, okay? But remember, I will ask you to do at least one problem on your first test using this limit definition of derivative. So I want you to be able to know how to do all this work. But we're not going to do this work every time we need to differentiate. So That's where this power rule will come in very handy. So using the power rule, I'm going to find the derivative of 1, 2, 3, 4 different functions. But guys, I typed up so many different things. I should read this with you. We use the prime notation to express the derivative of f. So if you have f of x, what you and I will be doing from now on is we're going to find f prime of x. Okay? How do you read this? We say f prime of x, and this is the derivative of f of x. What does that do? It will find us the slope of a tangent line at any given x value. Okay, it's gonna be a, when we have this function, we can plug in an x value. That's going to give us a slope of a tangent line. Okay, often we write y prime, read y prime, to denote the derivative of f prime. Another common way to express the derivative of y with respect to x goes like this, okay? It's really, we have y equals f of x, or y equals f of x, and what we do is we take the derivative of both sides with respect to x, okay? So the notation looks like this, d over dx, okay? So if you put this fraction together, that's how we have this dy over dx. dy over dx, this means derivative of y, okay, what's on top of the fraction? Derivative of y with respect to x. And sometimes writing it this way will be better because sometimes we will find something like this. Take a look. We may find something like dy dt. Well, in that case, we are differentiating the function y with respect to what variable? T, but that's for later, okay? That's for later. For right now, I just want you to know it's the same thing, just we're using a different notation. dy dx, okay? Or y prime or f prime of x, okay? All right, so I'll find this, okay? So starting with the first one. What is this notation, right? What is this notation? So let me talk about this. They want you to find the derivative of x squared. Okay, that's what they're asking us to find. They're telling us to differentiate x squared. Okay, let's find the derivative of x squared with respect to x. And it goes like that. It is super easy, okay? It is simply 2x to the first power. Or I'll just write this as 2x, okay? And you may wonder where I got this from, okay? This is what I did. I wrote down this 2, the original exponent of 2, in front. That's how I have a new 2 here, right, in front. And after what I do is I need to go down 1 from the original exponent. Remember, the original exponent was 2. 2 minus 1 is 1. So the new exponent is 1. That's the power rule, guys. That's really it. That's really it. So, if I give you something a little different, if I give you find the derivative of, let me give you something else. 5x to the 7th power. I made the example a little bit extreme so that you can see this power rule. What do you have to do? You have to multiply this original exponent. You have to bring this down, okay? Bring this down. But come on, when it comes down, there is a 5. So what you have to do is you have to multiply 5 times 7. So the new coefficient is 35 and the new exponent. What do you think? We have to go down one from 7. So the new exponent is 6. That's how you find the derivative. All right, I think it's easier to pick up on this rule by looking at a whole bunch of patterns. So let me give you another one. What if you have 4 times x to the 11th power? Ooh, what if you have that? All right, let's use the power rule to differentiate this. You multiply the original exponent by the coefficient that you have. So if you do 4 times 11, you will get 44, right? Write the x, but what should be the new exponent? The old exponent was 11. The new exponent should be always 1 less than 11, which is 10. That's how you do these derivative problems. And if we can do this, we do not have to do the limit definition of derivative, like using the quotient rule and not quotient rule, I apologize. What was it called? Difference quotient. So let me do a couple more examples in this video, and then I will summarize the rule for you. Next one. Find the derivative of x to the 3rd power. What do? You bring down this exponent to the front. Oh, but there's nothing to be multiplied, so it's just going to be 3 times x to the what power? 2nd power. And this 2 is from doing 3 minus 1. You always have to subtract 1 to get the new exponent, okay? So if you could remember that, that will be great. Oh, you know what? I think I will. Oh, whoopsie, my eraser was too big. All right, let me do one more, or just keep on going. Now, what do you think? This one, I need to bring down the exponent of 4 to the front. And if there's a number, you have to multiply, but there's no number, so I'll just write down 4 x to the, what is the new power? 3, because 4 minus 1 is 3. You always subtract 1 from the original exponent. Let's look at the last one. Ooh, what about this? I have to bring down the original exponent of half down in front, okay? That's going to give me 1/2 in front, and x to the, what is the new exponent? So the new power should be half minus 1, right? Because I always have to subtract 1 from the original exponent. That is half minus 2 over 2, and that comes out to be negative 1/2. So the new exponent this time is negative 1 over 2. Always remember to subtract 1 for your new power, okay? And that is, guys, power rule. And I was going to do this as a pattern thing, but I ended up just kind of showing you what it is. But here is the rule. The power rule states that if you are finding the derivative of x to the kth power, something like this, what do? You bring down the k to the front. You bring down that exponent to the front. That's why we have this k in the front. And what about that new exponent? The new exponent will always be 1 less than that original exponent of k. So that's what it is. How about we do the first pages, the examples on the first page here. But by the way, am I even recording this? Yes, I've been. Okay, that's good. All right. Differentiate each of the following with respect to x. What are they asking us to do? Find the derivative. Okay, so let's see. We can call it y prime. I'll just say, all right, if y is x to the 5th power, y prime is, what do? You bring down that exponent to the front. So when that comes down, you have the 5 in front, and you will have x to the what power? The new exponent should be 4, because 5 minus 1 is 4. I'm done. See, if I were to do this using the difference quotient, oh, it would have been a lot of work, don't you agree? Okay, so let's go on. Oh no, I don't see an exponent. Well, what is the hidden exponent here? It is 1, right? So the hidden exponent is 1. So let's work with that. So what is y prime when y is x to the first power? What do you bring down? You bring down the exponent to the front. If you do that, you get 1x. But now, remember to subtract 1 from the original exponent. So what is 1 minus 1? Uh-oh, 1 minus 1 will give us 0. So x now has an exponent of 0. What is anything to the 0 power? It's not 0. I always get my husband with that question. I ask Michael, what is anything to the x power? Ask somebody. Half of the time people will say 0. It's not. X to the 0 power is actually 1. Anything to the 0 power is 1. So y prime is 1 times 1. It's simply 1. Okay? So anytime you have to find a derivative of x, it's just going to be 1. And I think that is one on another theorem. Oh yeah, right here. Oh no, never mind. That is it's about the derivative of a constant. All right. All right, let's keep on going. I'm on part D. It says y is equal to 5th root of x. Now I have to show you a little trick here. In order for you to use the power rule, you need to have an exponent written, like you have to write this in the form of exponent. So I will rewrite this. Rewrite y equals x to the what power? Notice if you have 5th root, that is the same thing as having 1 over 5th power, okay? So I had to rewrite this in exponential form, not a radical form, so that I can apply the power rule. Did I do any calculus yet? Not yet. I didn't do any power rule yet. I am about to do. Let us now find y prime. Bring down that exponent of 1/5. This one comes to the front. So you will have 1 over 5 x to the. Now you know what you have to do. You have to do your fraction subtraction. I need to do 1/5 minus 1. I always have to subtract 1 from the original fraction exponent. So I'm doing 1/5 minus 5 over 5. The new exponent should be negative 4 over 5. So I'll stick that up there, negative 4 over 5. All right. I hope you guys are watching this because I'm imagining if someone is just looking at these notes or, my work, I wonder if these will make much sense. So hopefully some of you are watching this. If you're listening to this, you're watching it. Oh, I forgot to do C. Let me go back up and do C, okay? C. If y is x to the negative 4th power, y prime must be, bring down that exponent of negative 4 to the front. So I will have negative 4 x to the, all right, I need to do negative 4 minus 1 for the new exponent, right? I always have to subtract 1 from the exponent, and that comes out to be negative 5. So the derivative is negative 4x to the negative 5th power. All right. Always remember to subtract 1. Let me do 2 more in this video and I will stop this, okay? Next one. Y equals 0.0 x to the 0.07. I mean, it looks a little different, but we're going to use the same power rule. Y prime equals, bring down that exponent of 0.7. So I'll have 0.7 x to the. Now for the new exponent, I need to do 0.7 minus 1. And if I do that, I will get negative 0.3. So the new exponent is negative 0.3. And that is the derivative of y. Okay, that is y prime. Last one. All right, I'll just give you the rule and I'll show you why that rule is true, okay? Derivative of any constant, what do I mean by constant number, okay, is always 0. So if they give you, hey, y is 2, what is y prime? It's simply 0. If they give you, hey, y is 56, what is y prime? Y prime is 0. And I can show you both in terms of graph, or I think I can go ahead and do, I can add a page and do this with you. Okay, let y be 2. If y is equal to 2, and I really like this power rule so that I want to apply this, well, I can rewrite this as y is 2 times x to the 0 power. Isn't that true? Because x to the 0 power is equal to 1. They're the same, right? So now let me apply that power rule. Bring down that exponent of 0 to the front. I will get y equals what? 2 times 0, right? 2 times 0 times x to the, I need to go down 1 from 0. 0 minus 1 is negative 1. That's why the new exponent is negative 1. Well, like who cares there, right? Because take a look at what happened over here. When you do anything times 0, this entire thing turns into 0. Oh, whoopsie. Guess what I forgot to put? I forgot to put the prime notation when I took the derivative. So don't forget to put the prime notation when you apply that power rule. So that's why the derivative at y equals a constant is always going to be 0, okay? That's using the power rule. But if you think about it, if you have a constant function, if I have a graph at y equals 2, okay? What would the tangent line look like at any given point? A tangent line will also be a flat horizontal line, and the slope of a horizontal line is always 0. So that's how we can connect it to the graphical explanation. But you see this very often. I don't like the picture. I'm gonna erase this. You'll see this very often, so they even made it into a theorem that the derivative of a constant function is simply 0. That is, well, I don't know, I sometimes call it ddx. Ddx of any constant c is equal to 0. So if they ask you to do something like, hey, what is the derivative of 4? Guess what? That is simply just 0. If you're taking the derivative of a constant, it's always 0. And that is, and from now on, we can just use that because I tried to show you why using the power rule. But I think that was enough for our very first video. I will come back. In fact, how about this? I'm going to stop the recording. How about you guys try this? Try these. Oh, I already wrote down try these. I'll make these into a Canvas quiz for you so that you can submit your answers just like that graphical limit problem. And if you get, 6 out of 6, that means you understood what we went over on this very first video. All right, I'll stop this now.